didn't finish it.
Oh my gosh.
Oh wow. He missed one problem. I missed half of the problem. You missed half of the problem.
At this point in your math career, like if you're not doing the homework,
What are you doing for life?
well, I mean, just that you're probably struggling on the test. Like,
Yeah,
I mean,
she won't give you a background on homework if you don't do it because you're just gonna fail a test.
right. I mean, at this, sorry, like, yeah.
You kind of are doomed to fail a test if you don't do this.
Yeah, no, if you haven't practiced it at all, I mean, unless you're just really smart.
Isn't our test tomorrow?
Yeah, we'll review today. Make it over. Most of it though, guys, there's there's not a ton of this section. It's more like, probably the bigger points are synthetic long division, being able to like, kind of manipulate it in that way. There's a few, yeah, no, you guys will be okay.
I'm feeling good about this test.
Good.
I forgot. See this one? I don't.
They were doing Pictionary in their class, so that's why we have here. No one ever wants a break in here. That's our break. Garrett.
Instead of learning anything new,
We're not doing anything new. We're just reviewing.
then instead of
Okay. All right. So in number 5, and again, sometimes the wording in our book is a little bit weird. It says determine if p of x has this as a factor. So they're basically asking, is 3x plus 1 a factor of either of these? Did I write the same thing down twice, or are they that similar? It's minus 2 plus 2. Okay. All right. So did you guys do synthetic to check this?
Yeah, I did.
Yeah, that's probably what I would suggest doing. So if we're doing this, we have to get rid of that 3. So this is a negative 1/3. Remember, it's kind of like you're solving, you're finding the 0. So this would be 9. Now, 0, right? Because there's no x to the 3rd. And then there's no x term. And so we're basically looking for a remainder of 0. If it doesn't have a remainder of 0, then it is not a factor. And so we don't even have to worry about the like dividing by 3 in this case, but
I know what I did wrong. I forgot the placeholders.
oh, the zeros.
Yeah.
So this one's super close because that seems like that should be 0, but it's going to be a negative 2, and which gives me a remainder of 4. So this one's no. And so hopefully you realize, well, if I flip that sign at the end, it'd be yes. But, to check it. So.
So you have to divide by 3?
Well, you do, but
Or is that, no,
that's only if you're trying to find the polynomial. We just want to know if there's a remainder of 0.
Do you divide the remainder?
Not the remainder. So everything else gets. So yeah, if you were doing this to figure out what the polynomial is, you divide all of those by 3, but not the remainder.
Okay.
The remainder is still negative 4, which is kind of strange. So obviously this one should work. It should be positive, negative, negative. And this is a negative 2, so there's a remainder of 0. Now if I wanted to know what the polynomial is, I'd have to actually divide this by 3. So just be careful about that if you're doing this type. Okay? They didn't ask for that, so the first one's no, the second one's yes. Remainder of 0 is what we're looking for. All right, number 6. They give us the 0 of the polynomial, and then they want us to find any remaining zeros. So they tell us negative 2 is the 0 of So they're giving us one of them. So we're basically going to take that one out of there. So now it should be remainder of 0 because they're telling us it's a 0. We leave the sign the same because they gave it to us as a 0. They didn't give it to us as a factor. So now, so what I'm left with here, this is the constant x squared. But I need to find the rest of my zeros. Now, in order to find the rest of my zeros, I have to factor this. And this isn't the most delightful thing to have to factor, but we've practiced this. Hopefully, the issue is that we have to multiply this first and last term together if you want to do it that way. So that's a negative 90 x squared, I believe, right? If you multiply those, negative 1x. So I want to multiply to negative 90, but add to negative 1. So they obviously have to be close in size. Oh, 9 and 10, huh? That'll do it. So negative 10x, positive 9x. That's how we're going to split that middle term up. So know that you still need to know how to factor this way, so or factor somehow this, like, you'd be able to factor a polynomial like this one. We take out a 2x here. We can take out a 3 here. So my two factors end up being 2x plus 3 and 3x minus 5. And so to make them equal 0, I just have to set each of them equal to 0. So then solve. So move the 3 over. So I end up with a negative 3 halves. Move the 5 over. So I get 5/3. So those are my other zeros of the function. And then negative 2 as well, if I wanted to include all of them. So that one wasn't impossible. I mean, it's not the easiest thing in the world, but hopefully still okay. All right. There's a lot going on in number 8. So they say a polynomial is divided by x minus 2 to obtain a polynomial with a remainder of 0. That means it's a factor. Has degree of 5 and a 0 at negative 3. All right, a lot going on here. So they tell me x minus 2 is a factor, I believe, because it says a remainder of 0. But then it also tells me it has a degree of 5 and then a 0 at negative 3. So what that means is, what's another factor if that's one of my zeros? If they give me that as a 0, what's a factor? Yeah, x plus 3. So this is a factor, so is that, because they told us remainder of 0. So they ask you for, give 2 zeros. So obviously this is a 0 and x equals 2 is a 0. They want 2 factors. There's 2 factors. And then what's the maximum number of zeros that it can have? If they gave us a 0 already and then its degree of 5 after that, it could have one more, so it'd be degree of 6. So this was degree of 5, but this one was another degree, so that'd be 6. Kind of a weird question there. Okay, so they said once I took this out, so I divided this out, then the value had a degree of 5. So that means I have like something like this, and it's being multiplied by x minus 2. So the highest degree could be a 6. That's all they were trying to say there. Sorry, that was not real. I'm not going to ask you anything like that. And then it said, what's the remainder when that original function's divided by x plus 3? If this is a 0 or a factor, what's the remainder going to be? 0. That's all. So this one was just trying to get you to think about different pieces of this. And then number 16. They give us a bunch of zeros. I'm not going to ask you one like this, but I think it's good for us to think about it. They give us the zeros of a fourth degree polynomial. They give us x is 0, -4, 2/3, and 1/5. They want us to be able to basically write this into a polynomial. So what I'm going to do is I'm going to write the factors out kind of as parentheses, but again, this one's definitely tougher than I would give you one on the test. If these are the zeros, we write the factors as x minus whatever that is. So our first factor would be x minus 0, so I just write that as x. My second factor would be x minus a -4, so I'd write that as x plus 4. My third factor would be x minus 2/3. Now you can leave it that way, however, it might be a little bit better to try and write that like with nicer numbers, I guess is what I would probably suggest. So like thinking back to like what that would look like. 3x plus 2, right? Because with 3x plus 2, I move the 2 over, divide by 3. And again, don't worry about this if you didn't get this problem. And then same thing with the next one, 1/5. So that'd be 5x plus 1, right?
It would be minus 1, because when you move it over, it becomes
But it, oh yeah, so shouldn't it be minus 2 though then, as well?
well, no, because like up there, like when you have to move, well, to make it 0, when you have to move the 2 over, it has to subtract.
Yeah,
So in order to make that a negative up there, you have to add.
I think we want these both to be negative, because these are both positive. It's always the opposite
Oh, yeah.
sign.
Yeah.
So sorry, yeah, no, you're right. But you caught it on the one and then the other. So this should be minus, this is minus. And then they wanted you to like FOIL that all together. So it was a big FOIL problem at that point. If you didn't get that, totally okay. I didn't ask anything like that on the test. I have the test written already, so I know that I did not ask you anything like that. But I think it's good to think about that. If you have those factors and the zeros, they kind of go together there. All right. But again, so these last couple didn't ask anything like that. Something like number 6 could be on there. Something like number 5, yeah, that's doable. Probably not in that same exact wording, but kind of that idea. Okay, so what we're going to do is talk about, like we typically do, just kind of a quick little overview of what's going to be on our test. And then you guys will have time to work on your review and your note card or cheat sheet. Sorry about this one. Hole punch is bad. That's not gonna work. I made the hole punch unusable, sorry. Alright. So in a minute here we'll talk about the sections that are covered, kind of like the main gist of each of them. And then you guys will have time for the review, note card, kind of all that stuff. I know it takes you guys to make it a while to make a good note card. And I want to give you that time. As always, feel free to bring questions to class if needed. Otherwise, you're also welcome to come in during AR tomorrow. If you guys need help at all with anything, working on the review. Please don't ever just like stop at a problem on a review, like if you're stuck on something. Feel free to keep moving on. Obviously, everything is different going throughout, so like just because you didn't get like the second question, I'd rather you guys work on as much as you guys are able to before you come in with questions. Okay. So again, you can use a graphing calculator and cheat sheet, just like we typically will do. Again, I've been hanging on to those cheat sheets for when you guys need them for retakes, but also for when we have exams. That way they're all here and you don't have to, hopefully you guys can kind of put them together as needed. So section 4.1 and 4.2 in here, this is where we started to talk about what a remainder actually means. So essentially what we were doing here was we were kind of writing things out that we were saying that, so like even just a quick, so we talk about quotients and remainders. I'll just do a quick example of what I mean. So if I have like 29 divided by 3. We wrote that as a quotient and a remainder. We basically said 3 times 9 is 27, plus 2 would be 29. So we could kind of write this out, showing that 29 divided by 3 is 3 times 9 plus 2. So it's like kind of writing it with that remainder. So being able to do something like that. In 4.4 is where we talked about long division. So you should be able to do a problem with long division. So I give you guys one where you have to do long division, one where you have to do synthetic, and one where you can choose either or. So, so you have to show me you can do each kind. There are certain types we know we can only use long division for, like if you're dividing by something with an x squared, we don't have a synthetic way to do that. So long division has to happen when we're doing something like that. All right, so then we learned about synthetic division and substitution. And on the test, I don't care how you write your solution for these. So if you write your remainder as a fraction, or if you just write this is my remainder, whatever it happens to be, like, so I think I say, right, like use whatever method. I just have a line for you guys to write your final answer on, so I know what you think the final answer is, just because there's kind of those goofy ones with synthetic that you still have to divide it. You want to write it out as a polynomial though. And then the last section that we did with 4-6 is where we started to talk about if something's a 0 or a factor, we have a remainder of 0. How can I find my other factors? So being able to use those factors and zeros. So either they give you a 0 of the function, or they give you a factor. Remember, both of these should have a remainder of 0 if they're factors or a 0. So that may be allow you to find other zeros or other factors from that. Questions at all? Alright, so you guys have the rest of the time to work on your note card, your cheat sheet, so full sheet of paper, one side. Your homework is listed there, it is in the book. I thought the book had a review this time, so I chose to use it. Hopefully that's okay. Let me know if something's weird or that doesn't make sense in there. Every once in a while the book has like a bizarre answer that just doesn't make any sense. Some of them are harder than I wanted. But